All right, guys. This is for Wednesday, page 186. The other ones, I think these are like 11 through 14. So this is probably one that I put on that working reference sheet. That it's tough to remember this one until you get used to it. So I put that on your reference sheet right now. And if you've created one, so basically, it's when we have an exponent. So we have some sort of value. I mean, this could be like 8 to the x, or it could be like 3 to the 4t. And so when we use these, we just follow the rules. So it's a to the u, so we reuse it, times the natural log of 8 times u prime. U is actually going to be 1, so that is my derivative. So these are just kind of like pieces that you can use. So a to the u, a, and this is u, so this would be 3 to the 4t times the natural log, of 3 to the 4t. Of 3, not to the 4t. Of 3 times the derivative of u, which is going to be 4. So then that would get moved out there. So we just kind of use these as quickly as possible. They're kind of like a memorization piece, but you got to memorize by doing. So let's just tackle something like this. At one point, does y equals 2t minus 3 have a derivative dy dt equal to 21? So we've got to take the derivative of this, and that's where these come into play, and this is where our old rules of natural logs and everything come into play. So let's find dy dt. So dy dt of 2 to the t power minus 3 is going to equal, going to be a to the u, so this is a and that's u, so that's going to be 2t times the natural log of a times the derivative of t, which is going to be 1, so it's natural log of 2, and then this whole thing's multiplied by 1, minus 0, because that's, the derivative of 3 is going to be 0. So my dy dt is equal to 2t natural log of 2. And then that's going to equal 21. So we're going to do some algebra here. 2t natural log of 2 equals 21. Divide that over. 2t equals 21 divided by the natural log of 2. And then, how do I get rid of this? Take the natural log of both sides. Natural log of that, natural log of this side. This is going to give me, that won't. Yes, it will. My brain just locked up. What did I do wrong? Oh, that's right. Duh. All right. So I take the natural log of both sides. That's what I did wrong. I forgot to take this of this side. So this is 21 divided by the natural log of 2. All right. So we have this. Now I can move this t out front. I get t natural log of 2. This is a property, and that's going to give me the natural log of 21 over the natural log of 2. Divide both sides by that, gives me t equals natural log of 21 natural log of 2 divided by the natural log of 2. And then from there, you can plug that into your calculator, or you can expand it or whatever. So let's look at it this way. If you guys want to keep going with this, let's just practice our properties. You can plug it in your calculator right there. If we practice our properties, it's division, so we're gonna subtract. So the natural log of 21 minus the natural log of the natural log of 2, all over the natural log of 2. And so you do the math on that thing, it's going to give you 4.0 4.921. So at 4.921 seconds, we're going to take that and plug it into our original. So I'm running out of room over here. So we're going to say f of 4.921 is equal to 4.921 minus 3. You'll plug that into the calculator, and then that'll kick out your y value, which I believe is 27.297. So this is going to be 27.297. Sorry guys, got a little crowded there. So my point, at what point does this happen? T is equal to 4.921, and my y value is 27.297. So the big thing for today is utilizing this derivative of an exponent, a to the u, it doesn't change, natural log of the base, times u prime. You'll have application problems with it, is where we're going to use it a lot. And then let's not forget our rules, like natural log with an exponent. We can move the exponent to become a coefficient. When we're dividing natural logs, we can subtract them. Here, don't forget, you start plugging this stuff into the calculator and you're going to get funky decimals, but go ahead and go with them. You'll be fine. Other than that, that is how you deal with exponents and a derivative. We're turning it into a natural log so we can use the natural log properties to make it work. Good luck, guys. See you soon.